New Syllabus Mathematics Book 2, updated 7th edition, chapter number 1, primes, highest common factors and lowest common multiples. Exercise 1b, question number 3, find the largest whole numbers which is a factor of both 42 and 98. The largest whole number that is a factor of 42 and 98 is known as the highest common factor, HCF, of these two numbers. The question aligns with the definition of the HCF, which states that HCF is the greatest number that divides each of the two or more numbers. In this case, we need to find the largest whole number that divides both 42 and 98. So let's factorize both numbers. 42 factors into 2 times 3 times 7, and 98 factors into 2 times 7 times 7. The HCF is the product of the common prime factors, which are 2 and 7, while the rest are uncommon factors. Therefore, the HCF of 42 and 98 is 2 times 7 is equal to 14. Hence, the largest whole number that is a factor of 42 and 98 is 14. In other words, 14 is the greatest whole number that can divide both 42 and 98. No other number greater than 14 can divide 42 and 98. Question number 4. The numbers 792 and 990 written as the product of their prime factors are 792 is equal to 2 raised to the power 3 times 3 raised to the power 2 times 11, and 990 is equal to 2 times a 3 square times 5 times 11. Hence, find the greatest whole number that will divide both 792 and 990 exactly. This statement matches the statement of question 3. We need to find the greatest whole number that will divide both 792 and 990 exactly. The prime factors of 792 are 2 times 2 times 2 times 3 times 3 times 11. The prime factors of 990 are 2 times 3 times 3 times 5 times 11. The HCF is the product of the common prime factors, which are circled in red, and their product is 2 times 3 times 3 times 11 is equal to 198. Therefore, 198 is the greatest whole number that will divide both 792 and 990 exactly. This also means that 198 is the only greatest number that can divide 792 and 990. No other number greater than 198 can divide 792 and 990. Question number 5. The numbers 176 and 342 written as the product of their prime factors are 176 equals 2 raised to the power 4 times 11, and 342 is equal to 2 times 3 square times 19. Hence, find the smallest whole number that is divisible by both 176 and 342. In questions 3 and 4, we found the greatest whole numbers. Now, in this statement, we will find the smallest whole number that is divisible by both 176 and 342. In other words, we are finding a number that is a multiple of 176 and 342 at the same time. This number is called the LCM of 176 and 342. For example, the answer to the question is 30,096. This means that 30,096 is the smallest number divisible by both 176 and 342. No other number less than 30,096 is divisible by 176 and 342. There are numbers greater than 30,096 that are divisible by 176 and 342, but there is no number less than 30,096 that is divisible by both 176 and 342. And now let's factorize 176 and 342. 176 factors into 2 times 2 times 2 times 2 times 11. 342 factors into 2 times 3 times 3 times 19. Since LCM is the product of common and uncommon factors, Therefore, the LCM of 176 and 342 is equal to 2 times 2 times 2 times 2 times 11 times 3 times 3 times 19 is equal to 30,096. Therefore, the smallest whole number that is divisible by 176 and 342 is 30,096. Take a look at this example. We are finding the least number that is divisible by 20 and 40. I'm going to write the multiples of 20 and 40. Multiples of 20 are 20, 40, 60, 80, 100, 120, and 140, and so on. Multiples of 40 are 40, 80, 120, 160, 200, and so on. You can easily find common multiples between 20 and 40. But the smallest common multiple, which we call the LCM, is 40. Therefore, the LCM of 20 and 40 is 40. There are common multiples greater than 40, like 80, 120, and so on. But 40 is called the LCM. The statement of question 6 is as follows. Find the smallest value of n such that the LCM of n and 15 is 45. Here, the LCM of 15 and n is given as 45. We need to find the number that, when paired with 15, results in an LCM of 45. Let's factorize 15 as 3 times 5 and 45 as 3 times 3 times 5. The prime factors of 45 are the product of the common and uncommon prime factors of 15 and n. Therefore, the possible prime factors of n are 3 times 3, which gives us the value of n as 9. The LCM of 9 and 15 is indeed 45. It is important to note that the possible prime factors of n can be 3 times 3, 3 times 5, or 5 times 5, as these are the prime factors of 45. However, choosing n as 3 times 5 is equal to 15 would result in an LCM of 15, not 45. Similarly, selecting n as 5 times 5 is equal to 25 would give an LCM of 75, not 45. Therefore, the only valid factor for n is 3 times 3, as the LCM of 9 and 15 is 45. I hope this explanation clarifies the question.